Section 6.2 is dealing with transforming random variables, and transforming and combining. Transforming is kind of a review. Combining is not. So I'm going to go through this kind of fast because it is review. Recall that whenever we do a linear transformation on every data point in a data set, every observation in a data set, that if we multiply every value by b and add a, it doesn't change the shape. The shape stays exactly the same. The mean or expected value is multiplied by b and you add a to it, kind of like what you would expect. However, for the standard deviation, multiplying by b multiplies the standard deviation, but adding a does not change the standard deviation, because when you add a constant to a data set, it just shifts it. It doesn't change the spread. What about the variance? If we multiply a random variable by b, so if we make a new random variable y that is b times x, how is the variance of y related to the variance of x? Well, if you remember, the standard deviation of y is simply b times the standard deviation of x. The standard deviation of y, you just multiply the standard deviation x by b. So to get this into the variance, we need to square both sides. If we square this side, we get the variance of y. If we square this side, we get b squared. And then we square the standard deviation of x, we get the variance of x. So I just wanted to point out to you that, we say we multiply measures of spread by b. Well, you multiply measures of spread by b if they're in the same units that the original data was in. Variance is not. Variance is the square. So just be careful about that. You don't multiply the variance by b, you multiply the standard deviation by b. El Dorado Community College. So again, in order to save a little bit of time, we've already done this in the notes. How do you calculate the expected value and the standard deviation of a data set? Let me pause the video and I'm going to do it real quick, and then I'll just walk you through it real quick. All right, so just to review how to calculate this. To find the expected value, to show our work, first of all, look up the formula on your formula sheet if you want. It's the one that looks like this, right? It says you take the outcomes times the probability and add them up, okay? So I need to show my work, even though I'm going to use my calculator to calculate it. So I take the outcome times the probability, plus 13 times 0.10, plus 14 times 0.05, plus ... However, in order to calculate it, I'm going to put the values in my calculator. I'm going to make an X list, a probability list. Open up a calculator page. Menu, statistics, stat calculations, one variable statistics, number of lists 1. The values are the X's. The only thing that's new with these is the probabilities. So the mean is 14.65, the standard deviation is 2.06. So put down that, then interpret it. We would expect a randomly selected EDCC kid to be enrolled to take 14.65 credit hours on average. For the standard deviation, right, to calculate the standard deviation, again, we use the variance formula. We need to remember to take the square root of the variance formula. To set it up, we take 12, our outcome, minus the mean, square it to get the square deviation from the mean, weight it by the probability, plus 13 minus 14.65 squared times 0.1, plus 14 minus yada yada yada, ... And then we just get the value on our calculator. This is the average distance from the mean. The number of credits taken by a randomly selected kid typically varies by about 2.06 credits from the mean of 14.65. Create a histogram. So let me refresh your memory on how to make a histogram. Data and statistics page. Put your X's on the X-axis. Don't just put in your probabilities and make a scatter plot. Nope, nope, nope. Go to menu, plot properties. We want to add a Y summary list. So that would be the distribution. I would say this is a trimodal or multimodal symmetric distribution. All right, so suppose the community college charges a set fee of $500 to cover technology costs and charges $100 for each credit. So this is the cost of tuition. It's $100 times the number of credits, which was X, plus 500. If you remember, the expected value of X was 14.65 credits, and the standard deviation of X was 2.06 credits. So find the probability distribution for C. I don't want to write that down, but on the calculator, we could just make a new variable called C. The formula is 100 times my X, hit the vars key, select your X's, plus 500. So that's the distribution. I could write it down, but it's basically the tuition costs and the associated probabilities, right? Those two things. And we could even take a look at the shape of it if we wanted to. There's tuition costs. Notice the shape kind of looks the same, right? I mean, it should. It's just a linear transformation on the data set. It doesn't change the shape. So how does it change the mean and standard deviation? Well, the mean of C, the mean is exactly what you'd expect. If you multiply by 100 and add 500, then you just take the original mean, multiply by 100 and add 500 to it. That's 100 times 14.65 plus 500, which is $1965. That's the average tuition. Standard deviation, not what you would expect. You do multiply by the 100, however, adding doesn't change the spread. So you just take 100 times the 2.06 and you get $206. So the average tuition is going to be about $2,000 with a standard deviation of about $200. How does the shape, center, and spread change? Well, the center changes like that, the spread changes like that, and the shape doesn't change at all. Scale changes, but the shape doesn't. Scaling a test. All right, I think we skipped this one in class, but I'm going to do it here in case you guys are interested. In a large introductory stat class, the distribution X of raw scores on a test was approximately normal. This is scores. So the expected value of X is 17.2, and the standard deviation of X is 3.8. The professor decides to scale the scores, so the final score, let's call it the grade. The grade they get is going to be calculated by multiplying the raw scores by 4 and adding 10. Okay, fair enough. So if we got a 20, that was our raw score. He'd take 20 times 4 to get 80, add 10, and I'd get a 90. Find the mean, standard deviation, and shape of Y. Oh, I guess he decided to call it Y, sorry. So the mean, the expected value of Y, is going to be 4 times the expected value of X plus 10. Instead of using my calculator on the computer, I'm just going to use my phone calculator and do it real quick. 4 times 17.2 equals plus 10. So the average is going to be a 78.8. Standard deviation, you don't add the 10. The adding doesn't change the spread. Just 4 times the old standard deviation, 3.8, gives you 4 times 3.8 equals 15.2. You guys would not be happy with me if I curved a test so the average was 79 and the spread was 15. That means people are going to get pretty low scores. What about the shape? Remember, a linear transformation doesn't change the shape. So the shape is going to be the same as whatever the original shape was. They were approximately normal, so the shape is approximately normal. Shape doesn't change. What is the probability that a randomly selected student has a scaled test score of at least 90? Mean is 78.8. Standard deviation is 15.2. Probability that they get at least a 90. It's a 90 or higher. Menu, statistics, distributions, normal CDF, 90 or higher. Was it 78.8? 78.8. And 15.2. That means 23% of the kids are going to get A's. Ooh, that was actually a glimpse at I was putting together the test. So if you look at that, you might get a couple of questions from the test. We'll see. So what's the probability that the scaled score is at least 90? That's greater than or equal to 90. That probability is 23%. Was it 23.1 or? Yeah, 23.1. 0.231.